Okay. So good evening. Today I am myself Dr. Bhaskar Sharma. So I am working as a lecturer at LALAN'S Academy. So I am going to solve your this final year's chemistry board secondary 12 exam question papers. So this is, as you can see, this is the chemistry question papers. So in the first question, you can see what is the molarity of solution containing 5 gram of NaOH in 450 ml solutions. So you have to use the formula, simple formula. So molarity is equal to NV by V. Okay. So V is in liter. Okay. So what you have to do? NB is equal to WB by MB. Okay. Then V is in liter, right? So you have given WB is equal to 5 gram. Okay. Then MB means molecular weight of your NaOH, which is, 40 gram per mole. Then VML, V is already given, how much? 450 ml. So you have to convert 450 ml into liter, that is 0.45 liter, and put all these values into this following equations, and you will get the results. You will get the value that is 5 into your value is 5 by 18. Okay, so total you will get the molarity is equal to 0.28. This molarity you will get in the first questions. Okay. Then you in your second question, you just use your this Faraday's expression, which is W equal to Z Q and QT by T. So that is your expression, and from here you can get the hydrogen, how much hydrogen will be released. And similarly in this third question also you can get to know the this rate of the reactions using your kinetics equation, that is for first order reaction, as you can see, K is equal to 2.303 by T 10 base logarithm of A by A minus X. Using this expression also you can get to know the order of these reactions. So moving to second question, you can see second part, 4 number question. Highest oxidation state, that is +7. So manganese show the highest oxidation state, that is +7. So in the 3D transition series, and in the fifth question, write the chemical formula of the following coordination compound. So you can see it is mercury 1 tetracyano S cobaltate. That means your coordination compound is like that. So mercury is in the means outside the coordination sphere, that is in the 1 oxidation state, as you know. This is your metals. Then inside the coordination sphere you can write this tetrathiocyanate, that is cobalt SCN, tetrathiocyanate SCN -1. That means tetrathiocyanate S means the sulfur is connected with the metals. This is your structure of this coordination compound. Moving to next questions. As you can see in the 6 number question, in the following pairs of halogen compounds, which would undergo ascent to reaction faster. That means the reactant must be this primary alkyl halide, which is undergo very fast ascent to reaction. As you can see, this is your primary alkyl halide. This is your primary alkyl halide. So this will undergo very fast ascent to reaction in compared to this is tertiary alkyl halide, right? This is tertiary. So this will undergo fast. And in the second question, as you can see, this is how many carbons? 3, 4, 1, 2, 3, 4. So butyl iodide and butyl chloride. In this option also you can see iodide, which is better leaving group. This will show the faster ascent to reaction. So iodide is a better leaving group. So this will show the faster ascent to reaction. That means this is the correct answer. And in the 7 number questions, as you can see, the product's name after heating this ether in presence of hydroiodic acid. If you heat this this ether, benzyl phenyl ether, in presence of HI, what will happen? This bond will cleave. This bond will be cleaved in presence of heating, and it will give you the toluene. Toluene as a product, and another product is your phenol. Another product is your phenol. So these two products you will get in these equations, in this chemical transformation. So moving to next question. So starch and cellulose, okay, both have, what is the the difference? As you can see here, starch and cellulose both are actually biomolecules, right? So starch and cellulose both are polysaccharide, okay? So starch have 1,4-glycosidic linkage of alpha glycoside, alpha glucose. Means starch, you remember, starch have 1,4-glycosidic linkage of alpha glucose, okay? But in case of cellulose have 1,4-glycosidic linkage of beta glucose, okay? Beta glucose. So yeah, sorry. Oh, so you can see cellulose have 1,4-glycosidic linkage of beta glucose, and starch have 1,4-glycosidic linkage of alpha glucose. This is the basic difference between starch and cellulose. Moving to question number 9, you can see diazonium salt of aromatic amines are more stable than those of aliphatic amines. As you can see here, if I write here the diazonium salt structure, this is your aniline, right? Okay. If you treat the NH2 in presence of nitrous acid, what will happen? This will show this, okay? This is your diazonium salt. So this will undergo actually resonance stabilization. How? Because this double bond, as you write, we can write this structure like that. We can write this structure like that. Okay. So you can write this structure like that. So what will happen? This will undergo this kind of resonance stabilization. So what will happen in this case? As you can see here, there is a positive charge developed here in this ring. Yeah, and there it is nitrogen, double bond nitrogen, this your lone pair, okay? So this will undergo resonance stabilization. This will undergo resonance stabilization. That means your diazonium salt is much more stable. Much more stable compared to your aliphatic amines, which can form the diazonium salt. In your aliphatic amines, there is no possibility for the formation of resonance stabilized structures. Okay, this is the basic difference. And in this OR option, you can see why do primary amines have higher boiling point than tertiary amine? In this question, you can write, see, primary amines, this is the structure. If I write the primary amine structure, this is your RNH2, right? This RNH2 undergo this undergo actually hydrogen bonding with your water molecule. So what type of hydrogen bonding it is? Intermolecular hydrogen bonding. Therefore, association will be here. So with the increase in association, boiling point will be higher for primary amine. Okay, because this will undergo hydrogen bonding with your water molecule, right? This is the hydrogen bonding, H bonding, intermolecular, right? Intermolecular H bonding. Inter, not intra. Okay. Therefore, this will undergo high boiling point. But in tertiary amine, there is no possibility. There is no hydrogen. So how can you? How it will undergo this hydrogen bond? So therefore, primary amine have higher boiling point. Okay. So moving to next question. So calculate the equilibrium constant of the reactions. So you can see here, you can calculate the equilibrium constant using this expression. So you know del Z is Gibbs free energy, right? Del Z is equal to minus RT natural log of K. K is the equilibrium constant, right? So as you also know that del Z equal to minus NF E cell. E net cell equal to minus RT natural log of K. So minus will be cancelled. So for this reaction, you see the number of electron transfer is 2. N is equal to 2. Because copper release 2 electron and silver also release 1 electron, but after this equilibrium, after this balancing both the equations, so N will be the 2. So as you put the here and value of N is equal to 2, then and also you calculate the this. So you can put here NF E naught cell. Okay, E naught cell is equal to RT natural log of K. From here, if you calculate, you will get the exactly K value using this expression. Okay, so you just put F value is 96500 coulomb, and your E naught cell is already given. How much? E naught cell is you are given. This is 0.46. You put all this term here. R value is 8.314 and T value is 298 Kelvin. So you will get the K value. Okay. So moving to this or option, you can see in this the question is given like that, Nernst equation and the EMF of the following cells. So for this also you just use this expression. This is the Nernst expression formula. E cell is equal to E naught cell. Remember, E naught cell minus 0.0591 by N 10 base logarithm of your this. This is will be the means this will be like that, copper. Okay, then magnesium 2 plus. Okay, in the bottom it is copper 2 plus and it is magnesium. Okay, so magnesium having solid. Okay, so copper is solid, so both have both concentration is equal to 1. So you can put here, and magnesium 2 plus concentration is already given, so it is 0.001. Okay, this is given 0.001. okay, and for copper 2 plus it is given like 0.0001. After putting this, and also you see the number n value is will be 2, means there is a electron transfer is equal to 2 in this balancing equation. Okay, after putting this, you will get this E cell. Sorry. Oh, sorry. Okay. थोड़ा सा आ जाना, क्लोज हो गया. एक सेकंड दे दिया. Start. So in this equation, you can see in the question number 10, you can just use these equations. So del Z, oh sorry, not coming. Huh? Okay. Oh sorry. So del Z equal to minus RT natural log of K. Okay, and del Z is equal to, you can see NF E naught cell. Del Z equal to minus NF E naught cell. ठीक है. Del Z is equal to NF E cell equal to minus RT natural log of K. Okay, you just put here del Z equal to minus NF E naught cell and minus RT natural log of. Okay, so minus will be cancelled, and you will be having you will see the n the value of n is equal to 2. So and put here all this term, and you will get the you will get the K value, because E naught cell is already given. E naught cell is how much it is given? 0.46. K you have to calculate. Okay, so you put here 2 into value of F equal to 96500 coulomb. Okay, into 0.46 is equal to 8.314 into 298 into 10 base logarithm of K. From here you will get the K value. Okay, moving to second questions. For the following questions, you have to calculate the Nernst equation. You have to write the Nernst equation and this EMF value. For this, you have to write the this EMF equation like that. E cell is equal to E naught cell minus 0.0591 by n 10 base logarithm of your this concentration of copper and concentration of magnesium 2 plus, right? Divided by concentration of copper 2 plus and concentration of this magnesium. You know these are solid, so these have concentration is equal to 1. So you put the value of magnesium 2 plus concentration here. How much? 0.001. Concentration of Cu2 plus concentration is 0.0001. After putting all this and value of n is equal to 2 from the chemical equilibrium reaction, means balance equation, you can see. So number of electron transfer is equal to 2. So and value of n is equal to 2. So you put here E cell. E cell is equal to, finally what you will write? E naught cell. E naught cell means E naught R minus E naught L. Okay. So then minus 0.059 by 2 divided by 10 base logarithm of, if you put all this will give you 10. Then of course E naught R you have to remember. So E naught R means reduction potentials. Okay, reduction half cells potentials for this this is equal to 0.34, and for this it is minus 2.36. okay, so this is the minus 0.0591 by 2 into 1. So after calculating all this, you will get E cell is equal to how much? 2.67 volt. This is the answer for this first one. Similarly, you have to calculate the for second one also using this same expression. Then moving to this question, here it is written define the conductivity and molar conductivity for the solution of an electrolyte and discuss their variation with concentration. So you can see use this expression simply. Conductivity is equal to how much? Conductivity you can see kappa. Kappa is equal to 1 by R, means resistance, into cell constant. Cell constant is nothing but L by A. Okay, into 1 by R. You put this, this is called, this is kappa, so this is called your conductivity. And molar conductivity, molar conductivity expression is like that. Molar conductivity means this lambda m is equal to, this is the expression, kappa into 1000 divided by molarity. M means molarity. Okay, so from molarity of your solution, M means आपका molarity of your solution. So from here you can calculate, you can write the expression using this. Okay, molarity, molar conductance and your conductance. So with the dilution molar conductivity increases. So conductivity will be increases. Okay, relationship. So again the what is showing that the half-life period of first order reaction is independent of initial concentration of reactant. So as you know, T half for a first order reaction is 0.693 by K. So you see there is no, in the expression there is no concentration term. So that means T half is independent of your concentration. As if you plot T half in the y direction and your concentration is in the x direction, the graph is look like. Graph shows look like. Okay, that means your T half is independent of your concentration. Okay, moving to this this question also. You just use this expression. Rate K is equal to 2.303 by T. Okay, 10 base logarithm of concentration of A by the concentration of A initial divided by A. Okay, so A means A0 means initial concentration, and concentration of A is equal to A minus X. Okay, A minus X. So here it is in the expression. Small a is given 1.24 into 10 to the power minus 2 mole per liter. This is given. Okay, initial concentration. Time is given. How much? 60 minutes. And small x, it is also given. How much? 0.20 into 10 to the power minus 2 mole per liter. So this is given. Okay, so you put here and you will get the rate constant. Okay, you will get the rate constant. Moving to this question also, it is written the reaction is of first order in A and second order in B. Okay, write the differential rate equation. For this also, you can see, you can write this like that. You can write, let's say this A is converted to product. Okay, for this expression, how it will write? Rate is equal to minus concentration of reactant dA by dt. Okay, is equal to d of product concentration divided by dt is equal to K into concentration of A. Okay, concentration of A, but first order, that is means 1. And in the case of so actually it is given like that, A and it is B squared. So you have to write what you write. So you can write this means minus dA by dt, minus dA by dt, and actually from here you can write rate is equal to minus dA by dt minus dB by dt is equal to K concentration of A concentration of B squared. This is your rate expression. Okay, concentration of A concentration of B square. So this is the differential expression. R is equal to minus dA by dt is equal to minus the concentration of B by dt is equal to R, that means R is equal to K A concentration of B square. And then here it is in this, see how is the rate affected on increasing the concentration of B by 3 times. So for that you write here R is equal to K concentration of A concentration of B square. Okay, let's say it is given concentration of B is equal to let's say concentration of A is equal to C. Okay, and concentration of B is equal to means it is given concentration of B is increased up to 3 times, that means 3C. Okay, so you put here in this expression and final expression give you R dash equal to K concentration of A means just you put here K concentration of A means C, and B means आपका B means 3C. Okay, 3C square. That means you will be getting R dash is equal to K 9C cube. 9C cube. So this is the final rate for this second question answers. Okay, R dash equal to K 9C cube. So it is again, it is given, you can see, calculate the magnetic moment of a divalent ion in aqueous solution of its atomic number is 25. So atomic number is 25. You have to remember atomic number 25 means your divalent metal is manganese. So manganese have atomic number 25. For this, you can write the electronic configuration is like that. Argon, argon 3d5 4s2. But it is given divalent, so you have to eliminate these two electrons. So if Mn plus 2, then what will form? Argon 3d5. That means you see there is 5 unpaired electron in this case. So this molecule is, so that means this is paramagnetic in nature, and for that you have to calculate the magnetic moment using this formula n into n plus 2 Bohr magneton. So n value is here 5. So you put here 5 into 5 plus 2. Okay, 5 into 5 plus 2, how much? You will be getting the dipole moment, means magnetic moment would be how much? 5.916. So this is the answer. And for this, explain why titanium hexaecho 3 plus is violet in color. You can see for the titanium, as you have to write the electronic configuration for titanium. So you write, then what will find? Titanium have electronic configuration is this, means scandium, remember, just wait, this, okay, yeah, so atomic number is 14, okay, so scandium, just wait for 1 minute, yeah. So you see the titanium have this configuration is like that. Titanium is argon, argon 3d 2 4s2. So in your complex it is titanium 3 plus. That means you have to remove here 2 electron, 1 electron here from D. So that means you will be getting argon 3d 1. So 1 unpaired electron is there in the D cell. That means you will observe 1 DD transition. That is why it is colored. And in the nickel tetrachloride also you can see this is also paramagnetic. This is also this is paramagnetic in nature. This is diamagnetic in nature. But both have this tetrahedral geometry. You can write the why it is so, because in this also there is 2 unpaired electron in this nickel tetrachloride, because chlorine is a weak field ligand. Therefore it is paramagnetic. But in nickel tetracarbonyl, you can see Cu4, Cu is a strong field ligand. So that will give you all the electrons will be paired while hybridization. So that means during sp3 hybridization all the electrons will be paired. So that means in this nickel tetracarbonyl there is no unpaired electron. There is no unpaired electron. That means this is diamagnetic in nature. Moving to this, draw the structure of geometrical isomer of this. So you can write simply, it is what type of coordination compound? This is A2B4. Okay. For this you just write like that. This is your let's say A. This is A, B, B. Okay. This is your trans. Okay. This is your trans, and this is your cis. Cis. Cis means you have to write here in this way. Okay, you can write A in this way and B here. Okay, so this will show actually what? Mirror image. So you can see 3 isomers. Okay, from here there are 1 mirror image here, and one is this is trans, and this is cis. Cis will show the this optical isomerism, means mirror image. So in this this you can write the 3 isomers, and this for this these two last B questions, you can see here is also cis this dichlorido bis oxalato. This complex will be actually optically active, because in this complex there is no plane of symmetry, but in this complex there is a plane of symmetry. Therefore this will be optically inactive transform. Okay, so you can see the primary, secondary, tertiary amines identification test. So for that you have to just use the Hinsberg test. Okay, from there using this Hinsberg test you just identify the primary, secondary and tertiary amine. And moving to your this, just wait, 18 question. Okay, moving to question number 20. In this also, what you have to use the expression this. K is equal to 2.30 by t 10 base logarithm of a by a minus x. From here, then after getting the value of k, you use the in the Arrhenius expression k equal to a into e to the power minus ea by rt. After putting the value of k and your exponential factor a and r and t, you will get the value of e. Okay, this is what the question is. And this equation and this chemical transformation, you can see this is styrene reacts with HBr. In this reaction, you will get, this is simply the Markovnikov addition of HBr across the double bond. What will happen? H plus will goes to this side, Br will goes to this side. So you will get the product is like that. The product will be like that. This is CH3, this is Br. Okay. In the second case, again it is Markovnikov addition. The product will be CH3, CH2, CH double bond. H plus will be going to this part. So CHCl here, and this is single bond. Okay. Then this is CH3. So again it is Markovnikov addition. Markovnikov addition. Both this. Okay. In the third, it is, see, HBr is added in presence of peroxide. That means this reaction is undergoing anti-Markovnikov addition of HBr. So that means H plus will be added to least number of the hydrogen, the carbon atom which have least number of hydrogen, where H plus will be added. So product will be like that. This CH2, CH2, okay, and it is CH2Br. This is your anti-Markovnikov addition, okay. In this case also you can see what will be the product. This will actually, what will happen, the mechanism is like that. So this will undergo initially this, like in this fashion double bond will be transformed, and this will give you a carbocation. So this tertiary carbocation will be much more stable. Okay, there is positive charge. This is this H plus will be added to here. Okay, so this will be positive charge. Though this tertiary carbocation is much more stable. Then in this next step, chloride nucleophile will attack here and give you the product. Give you the product. 1, 2, 3, 4. Okay, this is your Cl, this is your CH3. This is the product. Then moving to next question. Moving to next question, as you can see, this. Moving to next question. Moving to next question, you can see how to convert ethane to bromoethene. Okay, ethane means आपका this is your ethane, right? So how to convert to bromoethane? Bromoethane means you have to convert carry out the reaction ethane in presence of photochemically, in presence of light, H nu and bromine. So it is means substitution reaction. So CH3, it will give you CH3 CH2 Br. This is the product. Okay. In the second case, bromomethane to propanon. Bromomethane to propanon is this means you have to convert your methyl bromide into first methyl cyanide by treating with alcoholic potassium cyanide. Okay. Once the cyanide is formed, then methyl cyanide it will be reacted with methyl magnesium bromide, means this is your Grignard reagent. So this will attack here. In the second case, in the next step, then followed by hydrolysis, it will give you the propanon. This will give you the propanon. Okay. So this is your answer. Then benzene to biphenyl. In the benzene to biphenyl, what you will do? First, convert benzene into bromobenzene by treating with Lewis acid FeBr3. Once the bromobenzene is converted, then this bromobenzene is treated with sodium, two equivalents of sodium, and this will give you the dimeric structure. That is this. This will give you the dimeric structure. Dimeric structure means you can see here. Dimeric structure means this. This and this biphenyl. Okay. So biphenyl structure you will get. And in the D option, it is given ethyl magnesium chloride to propanol. How will you convert? You just, what you have to do? For that, you have to carry out this reaction. Ethyl, you treat with your ethyl magnesium chloride. Okay. You treat with ethyl magnesium chloride with formaldehyde. Means that means formaldehyde react with Grignard reagent will give you the corresponding magnesium, and in the further step it is hydrolysis and give you the propan 1-ol. Okay, this is very important reactions. And in this case, you can see the question is coming here: how many isomeric structure of alcohol will be formed, right? For this you just write. For this you just write one thing. Just wait. For that you see C5H12O. Okay, so you have to write the isomeric alcohol like that. So 1 2 3 4 5. 1 2 3 4 5. 1 2 3 4 5. This is pentanol. Okay, this is one. Then you can write also this like that. Means decreasing the parent chain carbon. So I am writing 1 2 3 4. One carbon will be here. Okay, so this is 1 2 3 4 5 like that. Okay, this is one more alcohol. You can write isomeric. Then you can also write this. Okay, this is tertiary neopentyl alcohol, like tertiary butyl. 1 2 3 4. Sorry, this is not the structure. So because 5 carbon, no, 1 2 3 4. So this is not. So you have to write this 1 2 3 4 5. This is one alcohol. Okay, so these are the structures you can write, and also you can write this also. This is your alcohol. Okay, so 1 2 3 4 5. So these are the alcohol structures. Okay, so and from here you can write propanol, this isobutyl alcohol. Okay, 1 2 3 4 5 isopentyl alcohol like that. Then this is neopentyl alcohol like that you can write, and also its IUPAC nomenclature. And in this option, OR option, you can carry out the reaction catalytic reductions of butanol. So if you convert the butanol in presence of what? In presence of butanol means this is 1 2 3 4 5. Okay, 1 2 3 4. This is your butanol. If you convert the catalytic reduction means platinum in presence of hydrogen. Okay, in presence of Raney nickel ore. So what will convert? This aldehyde will be converted to alcohol. So 1 2 3 4. 1 2 3 4. This alcohol. Okay, butanol. So moving to B option, B. So hydration of propane in presence of dilute sulfuric acids. So dilute sulfuric acid, what is? This is simple electrophilic addition across the double bond, followed by water. Means hydration means reaction is moving this way. In presence of sulfuric acid, first this double bond will move to H plus, and it will give you one carbocation, right? This carbocation will be further attacked by water because hydrolysis is going now. So this will give you this is your product. This is your product. And the reaction of propanon with methyl magnesium bromide followed by hydrolysis. Means in this case also you will get, here in this case you will get tertiary alcohol, but here it is secondary alcohol. Okay, how it is going? It is simple nucleophilic addition. Okay, acetone, then methyl magnesium bromide. So nucleophile will attack here, this will go here, and followed by hydrolysis. This will give you this structure, tertiary butyl alcohol. Okay, 1 2 3 4 tertiary butyl alcohol. This is the products. And then you see orthonitrophenol. Orthonitrophenol is more acidic than phenol. Why it is so? Because in this case, if I write orthonitrophenol structure, orthonitrophenol, right? This is O negative, OH, and this is nitro group, right? If I write the structure of this like that, actually this will undergo, after elimination of proton from here in aqueous solution, what will happen? This will give you O negative, right? So proton will be eliminated, and then NO2 means N double this. Okay, so yeah, so what will happen? So this. So this will actually undergo resonance stabilization like that. This will undergo resonance stabilization. So you can have too many resonating structure in orthonitrophenol. Therefore, this is the strong acid. Means the orthonitrophenol is more acidic in compared to phenol. But in case of phenol, you never get so many resonating structure. Furthermore, there is electron withdrawing group at the ortho position. Therefore, this is more acidic in nature compared to this phenoxide ion. Okay, so moving to your this ethanol has higher boiling point than that of methoxyethane. You can see ethanol is alcohol. First of all, alcohol undergo intermolecular hydrogen bonding. Because of intermolecular hydrogen bonding, it will show the association, and it has the highest boiling point compared to methoxymethane. This is your ether. Then orthonitrophenol is again more acidic than orthomethoxyphenol. In this case also, you just remember there is a nitro group which is electron withdrawing group that will stabilize your this species. Okay, this your phenoxide ion. So through resonance, therefore this will undergo therefore orthonitrophenol is much more acidic compared to methoxyphenol. So methoxy group is electron releasing, but nitro group is electron withdrawing. This is the main difference. And is in the D case, cyclohexanon from cyanohydrine in a good yield, but 2,2,6 trimethyl cyclohexanon does not. This means this reaction, cyclohexanon from cyanohydrine in presence of with the reaction of HCl, but this does not form cyanohydrine because this is sterically hindered ketone. Therefore, it does not undergo nucleophilic attack. Okay, this is the basic difference. So again, these are the some reactions. You can see organic compound, the molecular formula this with DNP reduces tolerances and undergo Kenizer reactions. Okay, Kenizer reaction means this must have alpha. This does not have alpha hydrogen, right? Okay, so for this you can follow the Kenizer reaction part, and then you just carry out this following reaction. Acetophenone, benzophenone is like that. Okay, then the next reaction, as you can see, this is also 1,2-dicarboxylic benzene, 1,2-dicarboxylic acid. When treated with thionyl chloride, it will give you this product. It will give you simply this product. The carboxylic group will be converted to CuCl. This will be converted to CuCl. Means the structure's name is thalloyl chloride. Structure name is thalloyl chloride. Okay? In this case, the structure's name will be hydrazone. Means ozone, hydrazone. Means there is the elimination of water molecule and give you the product PHC double bond N NH CuNH2. This is the product. With this hydrogen kind of reactant, this will give you hydrazone. Okay? So with this, you see in the C reaction, when sodium borohydride reacts with this, what it is? This alpha keto ester. Alpha keto ester. So sodium borohydride always mild reducing agent. So this will reduce selectively only ketone group, not the ester. That means your product is like that. CH3CH OH, you will be reduced to say OH, and ester group will be remain unaffected. So this is the product. And in this case, see, CrO3 is a strong oxidizing agent. We will give you the product this. This is alcohol to ketone. Yeah, so give reasons for the following. pKb of aniline is more than that of methylamine. See, aniline have these structures. So in this aniline, you can see nitrogen have lone pairs. So this lone pair actually undergo resonance stabilization. This lone pair actually undergo delocalization. Therefore, this is not easy to donate for any lone pair acceptor, okay, or H plus. So therefore, this is less basic because lone pair is not easily available for donation. So aniline is less basic compared to methylamine. So in the methylamine, the nitrogen lone pair is not conjugated. Therefore, this is more basic. This is the main the difference. Similarly, aniline does not undergo Fiedel-Crafts reaction. So Fiedel-Crafts reactions, benzene undergo, okay, but aniline does not undergo because again NH2 is NH2 having lone pair. So therefore, this undergo this can undergo this kind of conjugation also, or also at the same time this nitrogen this NH2 can conjugate this NH2 can bind with your Lewis acid, which is used in the Fiedel-Crafts alkylation reaction. Therefore, there is no formation of your product. But Gabriel phthalimide synthesis is preferred over synthesizing primary amine. Here you can write Gabriel phthalimide synthesis, which is very useful for the synthesis of primary amine, because in this case there is no formation of side product, that is secondary and tertiary amine. Only primary amine will be selectively formed. In the D case, aliphatic amines are stronger base than aromatic amine. So aliphatic amine, if I write aliphatic amine, any aliphatic amine, let's say this is your RNH2, okay, and your aromatic amine, this is aniline, okay, what I write. So this have nitrogen is lone pair is easily available for donation, therefore it is strong base in compared to aniline. In the aniline, the lone pair is used for conjugation, okay. This is the basic difference. So coming to these reactions, you can see aniline is reacting with the chloroform in presence of alcoholic KOH. This reaction name is carbylamine reactions. Here you can see the product is phenyl isocyanate. Directly you write the product name is phenyl isocyanate, PHNC. The product name is this, phenyl isocyanate plus KCl plus water. This is your product, right? In the second case, when phenol is treated with nitric acid, concentrated nitric acid, you will get 2,4,6-trinitrophenol, that is picric acid, 2,4,6-trinitrophenol, okay. This is your product. The name of this product is what? Picric acid. In this case, again it is benzene diazonium salt reacting with alcohol, and it will give you the benzene. See, benzene diazonium salt react with alcohol. Ethanol means reacting with your this CH2OH, and it will give you the CH3OH, methanol. So it will give you the what? it will give you the your benzene structure. So benzene will form along with HCl, along with nitrogen. Benzene will form. Okay. In this reaction, amide reacting with bromine in presence of NaOH. This is Hofmann degradation product. Hofmann degradation reactions used for the primary amine synthesis. That means the product will be one carbon less in your final amine. So that is C6H5 NH2. So aniline would be the your desired product. In the fifth question, benzaldehyde reacts with concentrated nitric acid followed by heating, and this will give you the benzene. Because in the first case, it will give you benzoic acid. Okay, it will give you benzoic acid, and further heating, CO2 will be eliminated and give you the benzene. And finally, in the you write this is ether synthesis reactions, Williamson ether synthesis reactions. Here you can see the product is C6H5OET. This is your product, Williamson ether synthesis. Okay. Moving to this reaction, this question. So, what are the essential and non-essential amino acids? You write here. See, essential amino acid means body cannot synthesize. Okay. Essential means human body cannot synthesize this. So we have to take it from either from foods. So the example of essential amino acids, you can have 12 amino acids. You can write from here lysines, phalines, examples. In non-essential amino acids means body can synthesize it. So here you can just write the example. Non-essential amino acid is serine. Then आपका serine and glycine. Okay, serine and glycine. In the essential amino acid, you can write lysine and your this phaline. Then what are the classification of vitamins? So vitamins are, you can see this is biomolecules, vitamins. So you can classify the vitamins into two categories. One is fat soluble, and another is water soluble. So, and then it is asked, name the vitamin responsible for the coagulation of blood. That is vitamin K. Vitamin K is used for blood coagulation. Then nucleic acid. So you can see the nucleic acid again. What it is? It is the biomolecules. Biomolecules, which is used for which is actually inheritance substance. Okay, which is present in your animals, human beings. So for that, so you just show the difference. DNA, deoxyribonucleic acid, and RNA, ribonucleic acid, ribose nucleic acid. Okay, so DNA, what is the basic difference? In DNA, thymine is present. Main difference is in DNA, thymine is present along with adenine, cytosine, and guanine. But in RNA, uracil is present. This is the basic difference. Uracil is present along with adenine, guanine, and cytosine. This is the basic difference between DNA and RNA. So this is the basic difference. Okay. So then you can see the this also this is coming from your conductivity part, electrochemistry part. Okay, and this is coming from your coordination compound. So Warner's postulates theory. Warner's postulates theory. What it is saying? Warner's postulates theory. It is saying that. So in a coordination compound, you can have secondary valency and primary valency. And secondary means coordination compounds have one central metal ion. Let's say L6. Okay, this is your coordination sphere, and this is your ligand. Ligand means donating 2 electron pairs. Means ligands donates 1 electron pair at a time to have metals. So this is your coordination number. Okay, this is the coordination sphere, and outside the coordination sphere, it is called ionization sphere. If I say it is if I written here Cl2, this is ionization sphere. Inside the ionization sphere, this is ionizable species, but this is non-ionizable species. Remember. So this is your coordination number. Okay, so you can write here in your this Warner's theory, you can have secondary valency. Secondary valency is satisfied by your coordination number. Secondary valency is satisfied by your coordination number. Coordination number means this is your 6. This is the coordination number. Okay, and L is your ligand actually. L is ligand. And primary valency is satisfied by the metal which is present in the oxidation state. Metal shows the oxidation state. Okay, so this is the primary valency. Okay, so this is what the question came in your this higher secondary second year final exam. With that, I have concluded my this video solutions for this question papers. Thank you. Okay. Yeah. বেশি elaborate কে গৈ যোৱা কিছু নহয়, টাইম লাগিছে।